discuss this problem. So again writing to the mechanism, so I have given, so writing mechanism, you have to write down the mechanism. So product is given to you and reactant is given to you, 2CH3 C, then you have a pH group here, double bond, and then you have CH2. If I treat with HA, if I'm writing HA, this means A minus is not going to act something like this, it cannot go to attack, this is simply acting as a catalyst, and the final product is given to you. So there is a benzene ring, and this you have, this side you have CH3, this side you have pH group, and there is a 5-member ring, you have CH3 and there is a CH3. So this is the final product and reactant is given to you. You have to write down the mechanism. You see, if you see there are two molecules, so mechanism writing, so you write mechanism, propose mechanism or write mechanism, same thing we can say in a different word. So so let me write mechanism. So you see what is happening. If you see 1 2 3 3 carbon plus 1 pH group, if you see this side, how many carbon we have? 1 2 3 4 5 6 carbon and 2 pH group. So this is a pH group, this is also coming from benzene, so 2 pH group. This seems like these two molecules has been dimerized. So one hint I have, these two molecules have been dimerized. So you see, if you take two molecules, you have the same product. So the number of molecules is 2, so you see 2 pH group, I have 1 1 2 pH group, 6 carbon, 1 2 3 4 5 6 carbon. So it gives me idea, that is I have two dimerized two molecule. So this means now I have a double bond here. On the double bond can attack as a nucleophile, so I need some electrophile and some nucleophile. And now in the same case, two molecules are dimerized, this means same molecule will act as electrophile and same molecule will act as a nucleophile. I can treat with H plus to make one molecule as electrophile and other molecule will be nucleophile. Now if you make one molecule electrophile, how will you do that? You can take H plus and double bond will attack on H plus, it will form a carbocation. So do you have a electrophile? Take the second molecule has a double bond. You attack the second molecule, you will get a electrophilic nucleophilic reaction, so you will have again a different carbocation. And in that case, now you do electrophilic aromatics. You see there is a if you have a benzene ring, so initially if you see benzene ring is attached to only one carbon. Now you see this benzene ring is attached to two carbon, this side, this side. So this means I have to go for electrophilic aromatic substitution also. So in the next case, you once generate the carbocation, you attack this benzene ring on carbocation, that is generated carbocation, and then lose H plus, you will get the product. So this is enough hint. I will explain once again. What you have to do is, I have said this molecule has dimerized, the first thing. Second thing I said, if you want to dimerize the same molecule, you have to take a one electrophile and one nucleophile. One electrophile you can generate because the medium is given acidic, acid catalyst, so H plus you can attack on a double bond, you will generate a carbocation, that is electrophile. So you have generated the electrophile. Now this same molecule can act as a nucleophile because I have a double bond. So the previous molecule that you have generated electrophile, attack this one and you will get a carbocation this time again. Now we said, you see final product, this benzene ring is attached to two carbons. So this means this carbon, one carbon is already attached to the benzene ring. You can generate the other carbon that is connected to the benzene ring only by electrophilic substitution reaction. So attack the benzene ring as so third time you take the benzene ring as electrophile, attack on the carbocation, that is electrophile, lose H plus, you will get the desired product. So let me give you 2 minutes time and let me see how many of you are able to do this one. So do in the rough. You make the same copy, you make two column. This side should be your work and this side you copy just so make two column. This side you write your rough work or your work, and then this side you copy whatever solution we will give. Okay, let us discuss the solution. So what we can do is, I have CH3C, PH, double bond CH2, I have H plus. So this goes here. So I will generate a carbocation. So we will have CH3C, PH. If I generate carbocation here, I will have a stable carbocation. I cannot generate carbocation from here because that is not a stable carbocation. Now I will have something like this. Are you getting? Now in the next step, what I can do is I can write this molecule. So let us write CCH3, PH. This side I have CH3, and then there is a carbocation. Now if you take the next molecule, that is CH2, double bond C, CH3, PH. Are you getting? Now the next step, you attack this one here. You will get a carbocation here. So I am writing here. I think you have written the top one. So if you do this one, you will have CH3, CCH3. Now let us make PH as a ring, because in the next step I will need to attack. Now this carbon is attached to this carbon CH2, and then you have a carbon. Here you have a carbon. This carbon is connected to this carbon. Now this carbon is connected to the next carbon. Here you have CH3, and here you have a pH group. There will be a carbocation plus. Are you getting? So you will have CH2, CPH. So you see the same thing. This carbon is connected to this carbon. Now there will be a double bond because one half bond has already broken. So this carbocation, this will be positive charge. Now in the next step, I can attack here because this is electrophilic attack. So if I do this, what I will have? Are you getting? So if you do this, you will have. So let me write CH3. Are you able to see or not? Yeah. CH3, CH2, and then you have a ring. And now this double bond is basically broken. So we will have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 member ring here you will have. 1, 2, 3, 4, and then you will have C5. Are you getting? And there will be a positive charge because this double bond has broken. Are you getting or not? So this double bond is broken because I am breaking this. Positive charge will be here. Are you getting? So you will have here. So this carbon is connected to CH3. This carbon is connected to PH. You have the same thing. Are you getting or not? And here you will also have a hydrogen. Here also you have a hydrogen. So in the next step, what you can do? You can lose one H plus. So if you lose one H plus, you will get the desired product. So if you lose one H plus, now this is a benzene ring you will have. Are you able to see or not? If you lose H plus, you will have a benzene ring. And let us make things slightly better. So you have 1, 2, 3, 4, 5 member ring. So between this carbon and this carbon, you have a 5 member ring. So let us take 1, 2, 3, 4, 5 member ring. Carbon number is called, this is 1, 2, 3, 4, 5. This is just for numbering purpose. So this is 1, 2, 3, 4, 5. On carbon number 2, you have 2 CH3 groups. So I can add 2 CH3 group here. So CH3, CH3. On carbon number 5, I have C carbon, this connector. This carbon is connected to CH3 and PH. Are you getting? So you just copy this one. And you see, you have to do the same thing on one carbon. Benzene, one carbon is connected to carbon that contains CH3PH. So you see here, one carbon that is connected to carbon contains CH3PH. You see here, one carbon that is connected to carbon contains 2 carbon. Here you have. This carbon is connected to carbon. There you have 2 carbon. Another carbon that is connected to CH3PH. So on one carbon you have 2 CH3. You have here. Another carbon you have CH3PH. So that is the desired product you have to find. Are you getting or not? You can write the same thing, something like the original way. So you can write the same molecule that we have written in the initial way. So this is all about the mechanism for this reaction. So you can copy this one. So things are easy, not difficult one. So only thing is, so you see what are the concept we have. So we have discussed the concept of forming carbocation. And then the idea of the benzene double bond can act as a nucleophile, and in that case then benzene ring can also act as a nucleophile. So we are attacking the benzene ring and then we are losing H plus to gain the aromaticity, and we will get this compound. This is something called two benzene. So two molecules get combined. There is something coupling kind of reaction, or you can call dimerization kind of reaction. Did you get or not? So this is just something dimerization kind of reaction you have here. We'll discuss the next problem. You copy this one. Have you copied? Okay, go for the next problem. If you have copied or not, not copied. So just see on the top, anything missing from the top you can copy here. If you miss something from the top, you can copy. You can always copy at the end. Even you can make a pause if you are not able to copy this one. Okay, let us go for the next problem.